Yeah. So, good afternoon, students. So, today we are going to start a new chapter, okay, called Redox Reactions. So, we have completed periodic table lesson and we have completed thermodynamics and equilibrium, and this is the fourth lesson in our class 11. Okay, so which is Redox Reactions. So, do you have any idea about this, about the term redox? Do you have any idea about the term redox? Have you heard of the term redox before anywhere? Yes or no? Am I audible, students? Am I audible and visible? Yes? Yeah. So a reaction in which oxidation and reduction both takes place. Very good, Roshan. So your answer is exactly correct. And this is the definition for redox reaction. Okay. So we are going to study about this redox reactions in detail in this lesson. Okay. Very good. Great. So first, let's start with the introduction. Introduction to redox reaction. So in our daily life, if you see, we use some things which involves this redox reaction. Okay. So one among that is battery. Okay. Battery. And the other one is combustion. On the gas stove, combustion reaction takes place, and it is an example for redox reaction. Okay. And in case of rusting, you all know what is rusting, right? So oxidation takes place there. So it is an example for redox reaction and the refining of impure metal. Refining of impure metal. Okay, so all these are some of the things which the redox reaction takes to learn the oxidation. First is electronic redox have two words. Okay, one is reduction and just a second. Students, can you able to see the screen now? Is it visible? Vishnu, Roshan, Vangtoy, can you able to see the screen? Yes. Can you able to see the screen, students? Yes. Okay. Oh. Okay, fine. Sorry for the interruption. So we will continue. Okay. So in the word redox, we have reduction and oxidation. And the definition says that the reaction in which oxidation and reduction reactions occur simultaneously. Simultaneously means at the same time. Okay. So at the same time, If both oxidation and reduction occurs in the same in a reaction, then we call those reactions as redox reactions. Okay. So now we will see the definition for oxidation and reduction according to classical concept. Classical means olden days concept. Okay. So let me start with the definition of oxidation. So we do have different definitions, okay, for both oxidation and reduction. So let me go one by one, okay. So first of all, oxidation means addition of oxygen or addition of electronegative element to a substance. Okay. So here itself, two definitions are given. One is addition of oxygen and the second definition is addition of electronegative element to a substance. Okay. So I will give you some examples so that you can understand. So here I have taken magnesium is reacting with oxygen to give magnesium oxide. So initially in the reactant side, if you see, we have only magnesium. Okay. Now, after the addition of oxygen to this magnesium, we are getting magnesium oxide. Okay. So, for now, I will give you the oxidation state of magnesium. Later on, I will explain you how to find out the oxidation state of each element. Okay. Don't worry. So, here in case of magnesium, the oxidation state is 0 because it is present in its elemental form. But in case of MgO, if you see, the oxidation state for magnesium is +2. Okay. So it means that magnesium has got oxidized. Magnesium has got oxidized by the loss of 2 electrons. Okay. So now here oxygen is being added to magnesium. So this reaction is an example for oxidation. All right. Now coming to the second example, sulfur is reacting with oxygen to form sulfur dioxide. So initially we have only sulfur and finally we have sulfur dioxide. Okay, oxygen has been added to the sulfur. So sulfur has got oxidized and this is an example for oxidation reaction. Okay, clear. So oxygen has been added. Now here in the third example, you see magnesium is reacting with fluorine to give magnesium fluoride. Okay, so here we don't have oxygen. Instead of oxygen, we have fluorine. So who is this fluorine? It is a most electronegative element, right? So if some electronegative element is added to a metal, then we have to say that the metal has got oxidized and the reaction is an example for oxidation reaction. All right. So addition of oxygen to an element or addition of electronegative element to another element is called as oxidation. Okay. Oxidation can also be defined in another two ways. So let us see those two definitions in the next part. So it is also defined as the removal of hydrogen or removal of electropositive element from a substance. Okay, just the opposite. Addition of oxygen or electronegative element and here removal of hydrogen or electropositive element. So let's see some example. So you see here CH4. CH4 is called as methane. Methane is reacting with oxygen to form carbon dioxide and water. So in the reactant, we have CH4. And in the product, if you see, carbon is bonded with oxygen. So hydrogen has been removed from the reactant. Okay. So the removal of hydrogen is also called as oxidation. Okay. So carbon has got oxidized because removal of hydrogen takes place. Okay. So hydrogen has got removed from the reactant. Now we will go with one more example. So we have H2S. H2S is treated with O2 to form sulfur and water. And here you see, initially in the reactant, we have H2S. But in the product, we have only sulfur. Means hydrogen has been removed. Okay. In the third example, you see, we have potassium hexacyanoferrate reacting with H2O2 to form K3FeCN6, K3FeCN6 with KOH. Okay. Now here if you see, we have 4 potassium in the reactant side, but we have only 3 potassium in the product side. Potassium is an electropositive element. Okay, it is an electropositive element. So initially we have 4 and we are removing one electropositive. So the removal of electropositive element leads to the oxidation of the metal, oxidation of the element. So and that element is iron. Okay, iron has got oxidized in this reaction after the removal of one electropositive element from its substance. Is it clear for all of you? So these are the 4 definitions for oxidation. Do you have any doubt here? Addition of oxygen or removal of hydrogen. Addition of electronegative element or removal of electropositive element is called as oxidation. So do you have any doubts here in the definition of oxidation, students? Is everything clear and okay for all? Yes? Okay. So now let's go ahead with the definitions for reduction. So it is the opposite of the 4 definitions which we have seen for oxidation. Okay. So reduction means removal of oxygen. What is oxidation? Addition of oxygen. And reduction means removal of oxygen. Okay. Removal of oxygen or removal of electronegative element. For example, HgO is giving Hg plus O2. So initially we have oxygen. Okay, initially we have oxygen attached to Hg. Hg is a mercury metal. Okay, so in the product side, if you see, we have only mercury. Oxygen has been removed from mercury. Okay, so this is called as reduction. This is called as reduction. Removal of oxygen is called as reduction. Okay, now here in the second example, you see. So we have FeCl3 reacting with H2 to give FeCl2 and HCl. Okay. So here in the reactant side, we have FeCl3. But here we have FeCl2. So here we have 3 chlorine. But here we have only 2 chlorine. You all know that chlorine is a electronegative element, right? So the removal of electronegative element leads to the reduction of the metal. Iron has got reduced. Okay, so this is an example for reduction reaction. Got it? So you see chlorine, one chlorine has been removed as HCl. So this is an example for removal of oxygen and the removal of electronegative element. Now we will go ahead with the other 2 definitions for reduction. Addition of hydrogen or addition of electropositive element. Addition of hydrogen or addition of electropositive element. So here you see, take this as an example. Initially we have CH2 double bond CH2. It is treated with H2 to form CH3 bond CH3. So now we have this reactant. This reactant is called as ethene and hydrogen is added to this. So we basically break this bond and add 2 hydrogens like this. So addition of hydrogen leads to the reduction of the substance. Okay, and the ethene has been converted to ethane. Okay, ethene has been converted to ethane. It means that it has got reduced. It has got reduced. Addition of hydrogen leads to reduction. Okay, so let's go ahead with one more example. So here we have HgCl2 reacting with SnCl2 to form Hg2Cl2 and SnCl4. So here we have only one Hg, but in the product side we have 2 Hg. Okay, so Hg2, mercury twice. Mercury is an electropositive element. Okay, mercury is an electropositive element. So initially we have 1 and finally we have 2. So one electropositive element has been added. So addition of electropositive element to the substance leads to the reduction of the substance. Okay. All right. Do you have any doubt? Do you have any doubt from the definitions, from the classical concept definitions of oxidation and reduction? Can you all able to understand all the examples which we have discussed under each case? Students say yes or no. Okay, Roshan is clear about the concept. What about others? Chikmagalur students, Vaishnavi, Vishnu, Mangtoy. Do you guys have any doubt here? Shall we go ahead with the next concept? I want all of you to respond. Please don't stay silent. Students from JNV Kurnul and Vaishnavi, Mangtoy, JNV Chikmagalur students. Can you all able to follow? Any doubt so far? I hope I am audible to you guys, right? Am I audible? Roshan, am I audible? Yes. Okay. Okay, fine. So now let's go ahead with the electronic concept of reduction and oxidation. Okay. Electronic concept means electron is going to get transferred. Okay. So it is an electron transfer concept. Electronic concept is nothing but electron transfer concept. So according to this electron transfer concept, the definition of oxidation is, to understand the definition of oxidation, I will take one element, okay? So I have taken sodium. What is the atomic number of sodium? What is the atomic number of sodium? Can anyone tell me the atomic number of sodium? Can anyone give me the atomic number of sodium? So we have studied the atomic numbers in the periodic table lesson in the beginning, right? So do you guys remember the atomic number of sodium? It's very easy, right? It is also given in the slide as dots. Just count and calculate the dots and let me know the answer. Very good. Yeah, very good. So the atomic number for sodium is 11. And what about for chlorine? What is the atomic number of chlorine? Very good. It is 17. It is 17. So now, if sodium lose one of its electron, if sodium lose one of its electron, if it loses that electron to chlorine, sodium will gain the positive charge since it has lost its electron. And since the chlorine has gained one electron, it will take negative charge. Okay. So, transfer of electron takes place. And now these two species, the cation and anion, Na plus cation and Cl minus anion will combine with each other and they will form a NaCl crystal. Okay. So transfer of electron takes place here and we can say that sodium has got reduced. Sodium has got oxidized. Sodium has got oxidized. So loss of electron is called as oxidation. According to electron transfer concept, oxidation means loss of electron. Okay, loss of electron. So I will give you some more examples also. Okay, so here you see, we have Fe2 plus getting converted into Fe3 plus and electron. So what has happened here? Initially, iron has lost only 2 electrons. But in the product side, iron has lost 3 electrons. That is the meaning, right? 2 electrons has been lost to form Fe2 plus and 3 electrons has been lost to form Fe3 plus. So that is the meaning. So when iron loses one of its electron, okay, it is moving from +2 to +3 state, which is actually called as oxidation. Okay, so during the oxidation by loss of electron, there is an increase in the positive charge from +2 to +3 here in this case. Okay, so if some electron is getting lost, then there will be some increase in the positive charge. It means that oxidation has taken place. Okay, so we will take one more example. So here you see, I have two Cl minus and they are losing 2 electrons and they are forming Cl2. Okay, so here the charge of chlorine is -1 and here the charge of chlorine is 0. Okay, so in the number line, if you see, we have 0, -1, -2, -3, etc. And here we have +1, +2, +3, etc. So, okay, so here chlorine is moving from -1 to 0. -1 to 0. Okay, so this is called as decrease in the negative charge. Decrease in the negative charge. So increase in positive charge and decrease in the negative charge is called as oxidation. Okay, from electron transfer concept, it is also called as loss of electron. Clear? Clear? So, or simply to remember, if you are going from the negative side to the positive side, it means that the element is getting oxidized. So here we are going from -1 to 0. And in the first case, we are moving from +2 to +3. So if you are moving towards positive direction, then you are doing the oxidation. Okay. So this will be very easy for you. Clear? If you are moving towards the positive end of the number line, then you are doing the oxidation and the electrons are getting lost. Okay. So now coming to the reduction. Reduction is the opposite, right? Loss of electron is oxidation and gain of electron is called as reduction. Example, sodium plus is taking 1 electron and it is getting converted to sodium. So here the oxidation state is +1 and here the oxidation state is 0. So there is decrease in the positive charge from +1 to 0. From +1 to 0. So we have 0 +1, right? From +1 to 0. It is moving towards left side, from positive side to the negative side. So it is reduction. Okay, and here you see, when Cl2, which is in 0 oxidation state, takes 2 electron, it will be converted to 2Cl minus. So it is moving from 0 to -1. It is moving from 0 to -1. So again, it is going towards left side, which means reduction is taking place. Okay. So increase in the negative charge. 0 to -1 means negative charge is increased by 1 unit, right? So here it is an example for reduction. Can you all able to understand the definition of oxidation reduction using electron transfer concept? Any doubt? Shall we go ahead with some examples? Shall we go ahead with some more examples? Yes. So, sodium reacting with chlorine, Cl2 to form Na plus and Cl minus. Okay. So, here sodium lost 2 electrons. Okay, sodium has got oxidized and the chlorine has gained the 2 electrons which has been lost by sodium and that have undergone reduction. Okay, because it is moving from 0 to +1, right? And here it is moving from 0 to -1. So 0 to plus means we are moving towards right side of the number line, oxidation. And 0 to minus means we are moving towards the left side. So it is called as reduction. Can you all able to understand? Any doubt? Shall we go ahead with the next set of concept? So this is all about the definitions according to classical and electronic concept for both oxidation and reduction. Now let us do some electron transfer reactions. Let us do some electron transfer reactions. So for this, I am going to take a set of reactions. Okay. So set of reaction in the sense I can say that I'm going to do some experiments. I'm going to take the reactions from the experiments. So initially in experiment number 1, I have a beaker, okay, in which the copper nitrate solution is present. Copper nitrate is CuNO3 twice. Okay. And you can able to see that the color of copper nitrate solution is blue. And a zinc rod is dipped inside the copper nitrate solution. This is the initial state of the system. Okay. Now, the copper nitrate solution. So here we have copper nitrate solution, right? So inside that copper nitrate solution, we will have copper 2 plus ion and NO3 minus ion. So if copper nitrate get dissociated, it will form Cu2 plus and NO3 minus, right? So we have these two ions, cation and anion inside the solution. Now, after some time, what happens? The intensity of the blue color is reduced. Intensity of the blue color is reduced. The dark blue color is, after some time, it has been reduced to light blue color. Okay. So that shows that the element, the zinc element, the zinc atom which is present in the zinc rod, so they are losing their electrons to the solution and it is getting, zinc is getting converted to zinc 2 plus. So because of this transformation from zinc to zinc 2 plus only, the color change is happening. Okay, so this is the intermediate stage of the experiment. And after some time in the final stage, what happens? The solution becomes completely colorless. Solution becomes completely colorless. Okay. So in the final stage. So the copper 2 plus ion which is present inside the copper nitrate solution, is now deposited as copper in the rod. Copper 2 plus is now deposited as copper in the rod. Okay. So how it would have been deposited as copper from copper 2 plus? By the gain of 2 electrons. Zinc has lost 2 electrons, right? So this copper 2 plus which is present inside the solution is gaining those 2 electrons from the zinc and it is getting converted to copper and getting deposited on the rod. Okay, so this is the experiment. This is the experiment. This is the final stage of the experiment. So we have zinc 2 plus also in the solution. That zinc 2 plus reacts with NO3 minus and it will form zinc nitrate at the final stage. So basically what happens? We have zinc rod in the solution, in the copper nitrate solution. And finally, we have zinc 2 plus in the solution and copper is deposited on the solution. So zinc is getting converted to zinc 2 plus from zinc by the release of 2 electrons and copper 2 plus is getting converted to copper by the gain of 2 electrons. Okay. So zinc is able to release its electron more easily compared to copper. So the electron releasing tendency of these two metals, if you compare the electron releasing tendency of these two metals, zinc can able to release the electron more easily here in the intermediate stage than copper. Okay. So this is experiment number 1. So electrons are transferring from one system to the other and we can able to see some changes inside the beaker from the color change. Okay, so this is one experiment. Now I will take one more experiment. So here you see, Initially, I have silver nitrate solution in the beaker in which the copper rod is dipped. Okay, silver nitrate means what are the cations and anion I will have inside it? I will have Ag plus and NO3 minus. So these are the ions present inside the solution in the initial stage. After some time, the blue color starts developing. Blue color starts developing and they reach the intermediate stage. Okay, and the color of the rod also, it is getting changed. Okay, so what is the rod made of basically? It is made of copper. Now the copper releases 2 electrons to the solution and it is getting converted to copper 2 plus. It releases 2 electrons and it is getting converted to copper 2 plus. Now after some time in the final stage, what happens? The intensity of blue color increases. It is becoming more dark blue in color. Okay, it is becoming dark blue in color. That shows the color changes because of some reactions happening inside it. And that reaction is the Ag plus, which is there already in the solution, that Ag plus, it is going, that Ag plus, which is here, okay, that is going and getting deposited on the copper rod. That is getting deposited on the copper rod. Okay, this is what is happening. And because of this only, we observe the color change. And the NO3 minus is also present inside the solution, right? So that NO3 minus will react with the copper 2 plus present in the solution and it is getting converted to copper nitrate. So what happens finally? Initially we have a copper rod and Ag plus in the solution, and after some time copper is losing its electron and turning to copper 2 plus, and Ag plus is gaining the electron and it is getting converted to Ag. It is getting converted to Ag. So copper is releasing 2 electrons and silver is gaining 2 electrons. Okay. So now the electron releasing tendency for these two metals, if you compare, copper is having the more electron releasing tendency compared to silver. Okay. Copper is having the more electron releasing tendency compared to silver. Can you all able to understand? Now, if I compare the three metals, zinc, copper and silver, which element has the highest tendency to lose the electron? In the previous experiment, zinc has the highest tendency, right? Now, if I compare copper and silver, copper is releasing its electron more easily compared to silver. So, this is the electron releasing order for these three elements. Okay. Zinc is more reactive and that's why it is able to release its electron more easily. So, I will talk about the more reactive and less reactive elements in the upcoming slides later. Okay, so this is the order of electron releasing tendency for these three metals from these two reactions. Okay, from the observation we made from these two experiments, I can say. Can you all able to understand? Any doubt? Shall I differentiate the oxidation reduction definitions? Do you have any doubts in the electron transfer reactions? The two experiments which I have discussed in the electron transfer reactions. Is everything clear, students? Okay. Good afternoon, Jain Vishimoga students. You have joined late, it seems. But anyway, can you able to understand and follow? Okay, let's go ahead with the difference between oxidation. Let me summarize, okay? Let me summarize in a tabular form. So what is oxidation? Addition of oxygen or addition of electronegative element. Reduction is removal of oxygen and removal of electronegative element. And removal of hydrogen or electropositive element is oxidation. Addition of hydrogen or addition of electropositive element is called as reduction. Then according to electron transfer concept, Loss of electron is oxidation and gain of electron is reduction. Got it? This is the summary of both classical and electronic concept of oxidation and reduction. And after this, we have discussed about the electron transfer reactions, and from that, we have studied the element which has the more electron releasing power can lose its electron compared to the other. Okay, so these are the things we have discussed so far. Now, the second topic for today is oxidation number. Oxidation number. What is an oxidation number? Can anyone give me the definition for oxidation number? Can you guys give a try for it? What is an oxidation number? Definition. How can you define the oxidation number? Any idea? Just give a try whether it is right or wrong. No problem. Okay, don't worry about that. Just try and give me an answer for the definition of oxidation number. Okay, number of loss of electron, number of oxygen atoms added. Number of oxygen atoms added is oxidation number. Can you refine your sentence little bit, Vishnu? Vaishnavi, Roshan, Jane, Vishimoga, Vangtoy, can you guys try the definition for oxidation? Oxidation number, not oxidation, oxidation number. Okay, let's go ahead. So it is the real or imaginary charge on an atom in the compound. Okay. So what is an oxidation number? It is the real charge or imaginary charge present on an atom in the compound. So I have a compound and a compound can have two atoms or more than two atoms, right? So each atom which is present inside the compound carries some charge. That can be real or that charge can be imaginary. So that charge is called as the oxidation number of that particular atom in the compound. Okay. So let me take one example so that you can understand. So I have taken HF. HF is a compound. Okay. It is it contains two element or two atom. One is hydrogen and the other one is fluorine. Okay. And also there is a bond between the hydrogen and fluorine. And we all know that each bond will have two electrons, right? Each bond will have two electrons. And since fluorine is highly electronegative in nature, what will happen? What is meant by electronegativity? The tendency of an atom to attract the shared pair of electrons towards itself. That is called as electronegativity, right? So even though we have two electrons in the bond between hydrogen and fluorine, one electron belongs to hydrogen and the other electron belongs to fluorine, right? But since fluorine is highly electronegative in nature, what it will do? It will pull the shared pair of electrons towards itself. It will pull the shared pair of electrons towards itself, And since it is gaining the electron from hydrogen, it is taking -1 charge. Only one electron is taken from hydrogen, right? So -1. And since hydrogen is losing one electron, it is getting +1. It is getting +1 charge. Okay. So what is the charge acquired by hydrogen? +1. And the charge acquired by fluorine is -1. So +1 is the oxidation number for hydrogen in this compound, and -1 is the oxidation number of fluorine in this compound. Okay. Can you able to understand now? So that charge can be a real charge or it can be an imaginary charge on each atom in the compound. And we define this as oxidation number. Is it clear for all of you now? Able to understand the definition of oxidation number? Yes? Very good. So now let's go for some rules to calculate the oxidation number. Okay. So we have studied about HF now, but we do have n number of compounds, right? So for all the compounds, we have atoms, and each atom will carry some oxidation number, right? So we need to study the rules to calculate the oxidation number for each atom present in the compound. Okay. Now coming to rule number 1. In elements, in the free state or in the uncombined state, each atom bears an oxidation number of 0. So what does this rule says? Elements in the free state or elements in the uncombined state has an oxidation number of 0. For example, H2. This is an example for element. Element means the bonded atom will be same. What is an element? The bonded atoms will be same. Okay. So both of them are hydrogen here in case of H2 molecule. So one electron belongs to one hydrogen and the other one belongs to the second hydrogen. So nobody is more electronegative than other. So what happens here? The charge or the oxidation number for this hydrogen is 0. And in case of O2 also, it is the same thing. Bonded atoms are same. So the oxidation number is 0. And in case of O3, all the 3 atoms are same. All the 3 atoms are same. So it is 0. And in case of P4, all the 4 atoms are phosphorus. So nobody is highly in electronegative value compared to others. So all of them will pull equally. So oxidation number is 0 for P4. And in case of S8, all the 8 atoms are same, right? So oxidation number is 0. And in case of magnesium means we have only one atom. It is in the free state or it is in the uncombined state. Okay, it is in the uncombined. There is no element bonded with this magnesium. It is in the uncombined free state. So the oxidation number is 0. And aluminium, 0. Sodium, 0. So if you keep all elements in the uncombined form, all the atoms will bear the oxidation number of 0. Clear? Able to understand rule number 1? So all elements in the free state or uncombined state has an oxidation number of 0. Shall we go for rule number 2? Do you have any doubt in rule number 1? Do you have any doubt in rule number 1, students? Shall I go for the next rule? Okay. Now, rule number 2 says, for ions composed of only one atom, composed of only one atom, the oxidation number is equal to the charge on the ion. Charge on the ion. So here you see, we have sodium plus. Sodium plus is an ion. It is a cation. And this cation has only one atom, which is Na. Right? It is a single atom. So if it has only one atom in its ion, then the charge on the ion is equal to the oxidation number. The charge on the ion is +1. So that is the oxidation number of this ion. Okay. Next, magnesium 2+. So we have only one atom called magnesium, Mg. So the charge on the ion is +2. So the oxidation number is also +2. In case of Cl minus, so Cl is a single atom and it carries -1 charge. So that is the oxidation number of chlorine. Okay. So you all have to note that for all alkali metals, the oxidation number will be +1. Who are alkali metals? Sodium is an alkali metal. Sodium is an alkali metal. And the group number for this alkali metal is 1. Group number for alkali metal is 1. Right? So all the group 1 elements will have the oxidation number as +1. So who are the group 1 elements? Lithium, sodium, potassium, rubidium, cesium, and francium. So all these belongs to group 1. So all of them carry +1 charge. Lithium plus, sodium plus, potassium plus, rubidium plus, cesium plus, and francium plus. Okay. For all the alkali metals, the number is +1. And for alkaline earth metals, alkaline earth metal means group number 2 elements. Group number 2 elements. So magnesium belongs to group number 2. So who are the other group 2 elements? Lithium, here beryllium, magnesium, calcium, strontium, barium, and radium. So all these elements belongs to group 2. So beryllium 2 plus, magnesium 2 plus, okay, calcium 2 plus, strontium 2 plus, barium 2 plus, and radium 2 plus. All the elements will carry +2. Okay, all the elements will carry +2 charge. And the oxidation number of aluminium. Oxidation number of aluminium in all its compound is +3. For example, let me take one compound of aluminium, which is AlCl3. So in AlCl3 compound, the oxidation state of aluminium is +3. Okay. And if I take one more compound, AlF3. So here also it is +3. And if I take one more, Al2O3. So here in this compound also the oxidation state of aluminium is +3. So if you take aluminium, in all its compounds that it forms, it carries only +3 oxidation state. Okay. So these are the points which you have to note down in your notebook. Okay. Because these things will not change from compound to compound. So it remains same. All right. Able to understand? Able to understand rule number 2? Yes. So this is enough for today. So we do have some more rules. Okay. Totally we have 6 to 7 rules. So the remaining rules I will discuss in the next class. So we have studied the classical concept, electron transfer concept, electron transfer reactions, and the definition for oxidation number. And out of the set of rules, 2 rules have been discussed today, which is used to find out the oxidation number. Okay. So do you have any doubts from today's session? Do you have any doubts from today's session, students? Okay. So thank you so much for attending the class. So please try to join on time from next class onwards. Till then, take care. Bye-bye. So I have launched a poll. You guys can give me your answers over there and then you can get ready for your next class. Okay. Thank you.